data science researchers. And when we go for optimization problem, also machine learning is a very important solution. So we can have the machine learning things for the optimization problems also, because by repeated training of algorithms, it will give a good result for the optimization problems by the repeated training. So normally for the optimization problems, we will have an objective function and the decision variables and the constraints. So we have to frame the objective function based on our problem. For example, if I want to have an objective function, that is, if we want to reduce the cost of a function, we can write our own functions and we can fix the decision variables there, and based on the constraints we can solve the problem. So the machine learning algorithm, we can train a machine learning algorithm based on our function, and we will be getting the accurate results with repeated training. So optimization problem is a good feature for a machine learning algorithm. And when we go for univariate optimization, so there will be a local minimum and global minimum. So these things will be applicable for the optimization problems. So machine learning can easily solve these problems with the local minimum values and the global minimum values, and the covariance analysis and the correlation. So what is the theory behind this correlation means? That is, we will be saying every data set, every field in the data set has an attributes. So we can find the relationship between different attributes. For example, if you are collecting a data set from 500 candidates, 500 students, we can have a correlation between the girl students and the boy students, or the first year students and the second year students. We can have a correlation between the different types of attributes. We can analyze the attributes, and also we can have an analytic approach between the less average students and the excellent students. So like this, we can have a correlation analysis and the covariance analysis between the different attributes in a data set. So if we gather a data set of students, we can have a correlation analysis based on their education level, or based on their sports level, or based on the extracurricular level. We can have a correlation analysis in data mining. And we can have a regression approach. So regression approach means usually all the websites are predicting the ranking nowadays. So how the ranking is determined means, if we are watching a video how many times, so we can fit a regression line, and that is known as unidimensional regression. So if a YouTube video is uploaded, we can find that how many watches, how many candidates have watched that video. So like that, we can have a regression analysis. If it is a latitude, longitude of the location. For example, when we go for Google Maps, if I go from one place to another, there will be a latitude and longitude. And based on that, we can have a multidimensional regression also. So regression analysis is another fact of machine learning algorithm. And what is the thing we are going to do is, so we have to apply the correct algorithm. The data is very important. Data is very important. That is, the exact accurate data is very important. If algorithms will be effective because it is a predefined one, and the methodology of algorithms are also described in by the experts. The data set we are going to collect is very important. It should be a quality data set. For example, if you are collecting your students' report, data set, it should be an accurate one, so that we can predict which student will be a better performer after 3 years or after his course completion. Like that, we can predict it. So the data is very important, and we are the gardeners. We are going to find the algorithms with the quality data. The program will be generated automatically by the computer tools. There are many tools for that. It will automatically do the programming. Only the data selection and the choice of the algorithm and the working principle of the algorithm should be familiar for us. And so this is the data set that is in the BigML tool. BigML is a tool. I think you can have a screenshot of this. BigML is a tool which was available in internet online. So BigML is a tool. Just with the Google account, you can log into this tool, and in that tool there will be sources like this. There will be a menu. So in this data set, there will be many inbuilt data sets. For example, this is a data set which represents a flower which is named as iris. So this is a flower. The name of the flower is iris. So this data set will be in this data set column. When you browse the internet, you see that when you just type big ML, the dashboard will get open. With the Google account, you can log into that. In that, these data set column, there will be many inbuilt data set. And also you can create your own data sets. So I have chosen the iris flower data set. So iris is a flower which may have 3 classifications. So one classification will be like this, another one will be in pure violet color, another one will be varying with the sepals. So there are 5 or 6 sepals here. So with the sepal and petal, this flower will get varied. So this data set will be available in this BigML tool. So here the sepal length and the sepal width will be given. And when you go for the algorithms, here the algorithms, machine learning algorithms will be having 2 ways, supervised and unsupervised. So when you open of the algorithm, it will automatically give the histogram of this algorithm. So it will classify all the data sets into these 3 varieties, iris setosa or iris versicolor or iris virginica. So into these 3 varieties, this algorithm will automatically calculate the data set. So it will classify the data set. If the data set is having 500 data set, it will automatically classify the variety of the flower. So you said knowledge of computer science is needed for this. Just we can go for BigML. When in Google you can type BigML, and with the Google account you can log in into that. The thing is you have to choose the data set. I have chosen this flower data set. Inside this there will be many type of data set. For example, there will be diabetes data set. That is the 500. There will be 500 data. In the 500 data, each and every people's blood pressure and sugar level will be there. So when we choose the data set and if you apply the algorithm, it will automatically throw this result. So what is the next step we are going to do is we have to analyze this results with the mathematical tools. So it will generate the report. So it will classify the data and it will generate the report. So BigML is a tool where we can use, where we can apply this machine learning algorithms will be directly predefined in this tool. So just you can click the data set, you can choose the algorithm, you can throw the result. And this again the BigML screenshot. I have chosen now that. So diabetes data set I have chosen. I have given some algorithm. Diabetes data set, each and every candidate's glucose level, blood pressure, and skin fold, every data will be there. It will automatically throw a histogram map. So based on that, we can analyze. So BigML is a tool where there is no need for programming knowledge or any computer science skill. Just you can type BigML and you can go through it. So you will have a clear idea about the machine learning. And these are all the things we should be familiar with, that which data set we have to choose. That is the problem domain. To solve which problem we are going to choose the data set, and we have to give the training data set and which algorithm we are going to choose and what will be the output. So this is the methodology of machine learning. So when you go for some tools, it will automatically, we will have a clear idea of the tools. So normally data sets, if we are going for a real-time project and if we are going to apply some real-time projects, so we can have the data many websites. So these are all the different types of websites where the data sets are available. And also you can collect the real-time data set. For example, you can collect it from the students, or you can collect it from the agricultural departments, or you can collect it from government websites. So we can have the search the data set and we can have many data sets as input and we can apply the algorithms. So we have to separate the useful information as well as useless information. Only the raw data set, we have to eliminate the unwanted information. We have to carry out only the good and useful information to have a good output. So that is the thing. Database of useful information should be carried out so that the results will be accurate. So the machine learning model, internally how it is processing is, the original data set is divided into 2 types. training set and test set. So in the training set, when we apply any algorithm, it will go for the training set and it will validate the set and it will give a predicted output. So the thing here is the data set will be divided into two parts, training set and test data set. And so when we examine a large amount of data set, we have to apply the machine learning algorithms. So this is the this is the only way to go for data science research. Machine learning applying machine learning algorithms is the only way. And the data sets will be divided into two parts. One is for training, another one is for testing. So when we go for the models, that is it can be categorized into three varieties: supervised learning model, unsupervised, reinforcement. So if we give a training for the machine learning algorithm, it is known as supervised model. If we are training and if we are not giving any output, that is known as unsupervised. Next one is reinforcement. So there will be many algorithms. So when we go, if you are interested in these algorithms, you can choose any one of the algorithms and you can learn. So there will be many algorithms. Usually regressions, decision trees, classification algorithms will be widely used. So here classification is widely used because before the previous slides, I have given that when we choose the iris data set, that is when we want to classify a flower or a leaf, we can go for the classification algorithms. So classification will classify the data like this or like this. That will be determined this. So it can go for, this is the classification approach. If there are 500 data sets, it will classify like this. So this is classification. And when we go for the classification algorithms, so the predicted value in the form of a matrix. So in this matrix, sometimes the prediction of the system will be correct, or sometimes it will be false. So that is the thing we have to take. There may be two cases. Sometimes the prediction will be correct or it may be false. So it may be positive or negative. So the term, this matrix representation is known as confusion matrix. When we go for classification, we have to consider only about the confusion matrix. We have to have a clear idea about the confusion matrix if it is a classification problem. And we have to find the absolute error. So when we go for that data sets, out of how many data set, how much of the predicted value is true, how much of the actual value is false. So like this, we have to find the prediction errors. So we have to find the prediction errors also. So that is, this is because a machine is going to predict or classify. So there may be errors and there may be some approximate values or there may be some output variations from our predicted value. That is, if we are planning for one output, the machine may throw some other output. So we have to find the error between these two values. So these are all the factors when we go for classification algorithms. We have to consider these classification algorithms and we have to go for this confusion matrix and for the absolute errors. That is, if our problem is a classification problem, we have to choose these two things. And we can go for regressions and naive Bayes approaches, naive Bayes and some decision trees and some production rules. And if it is functional approach, we can go for wavelet transformation and linear transformation. So day before yesterday, a resource person had a good lecture about neural networks. So neural networks can also create good deep learning models. So just we have to give the input and the output will be generated. Based on the output, we have to train our model to generate more number of results. So these are all the different types of machine learning applications, models where we can use. So based on our problem or domain, we can go for any of these approaches. So when we go for regressions, if we want to calculate the height versus age, so we can go for regression problems. When we calculate the children data set from 500 children or from school children or college children, we can have a regression analysis between the height and the age. based on the age, how much the students are having a height. So like this, we can have a regression analysis. This is classification and this is regression. So in the regression, we can find that the best fit output will be fitted in this line. So based on this, the regression model can be developed. And then we'll be saying this as linear regression. So these things can be automatically done using the BigML software, and also there are many softwares. If we want to write the codings for that, we can go for Python tools. Python. So there are different types of regressions. All these can be done using the machine learning outputs. All these machine learning tools, software tools, we can do all these problems based on the regression. Based on our different types of regressions we can do. And when we want to classify, that is when we go for classification, we will be predicting whether tomorrow will be cold or hot. And if we go for regressions, we will be predicting what exactly the temperature will be tomorrow. That is the difference between classification and regression. So when we go for classifications, we will be giving a generalized output for the next 10 days. How will be the climate? Like this, we'll be giving a generalized output. But when we go for regression, we'll be predicting the accurate output. That is, tomorrow what will be the prediction temperature? Like this, we'll be predicting. And next is some of the things we have to think about the machine learning, issues in machine learning algorithms. So I have already told you that the data should be proper. Just the data should be a proper one, and the dimensions of the data should be a good one. For example, we should have only the important attributes. Unnecessary attributes can be eliminated. So the multi-dimensional data based on the dimensions of the attributes should be very important. And then some of the uncertainty effects should be eliminated. For example, if a student didn't know his height, or if he is not aware of his percentage marks, it should be eliminated. So the uncertainty of the problems, because it may interfere with the machine learning model, and automated analysis should be done. That is a manual analysis. We should avoid some manual analysis. Automatically, the system will clean some data. It will clean the missing data. It will clean the normalized data. So we should go for automated tool. And the analysis of statistics is very important. And we can visualize the data in the form of distributions and scalability. That is when we go for more and more number of data sets, the results will be very effective. That is known as scalability. So we have to improve our input data so that it will be very effective. And the sampling. So if we want to take only some samples of the data set, there are many sampling techniques. So when we go for research methodology books, that is general research methodologies, there will be, you can see that there will be many sampling techniques. So we have to adapt any one of the sampling technique so that all the data should get into the algorithm. So the input should be very proper for this. So when we go for research methodology books, there will be many sampling techniques. Based on that, we have to have a sample. So sampling is very important. Pre-processing of data is very important. And then modeling relationships. That is the attributes, important attributes should be related. We have to create a good model. So these are all the things we have to be very cautious about machine learning algorithms. So there are many statistical measures available. You can take a screenshot of this. So if you are being a mathematician, if you are interested in variance, or if you are interested in regression analysis, or if you are interested in spectral analysis, or if you are interested only in the cluster analysis or density estimations, you can choose any of these statistical measure and you can apply them. You can choose the data set, you have to apply the machine learning model, and you have to focus only in this particular statistical measure so that you can get a good output, and you will be having some findings in your hand. So you will be having a good findings in data science so that you can predict the results with theoretical as well as mathematical proof. So these are all the statistical measures which we should apply after the analysis of machine learning algorithm, and we have to analyze the report based on the statistical measure. We can fit into any one of the measure and we can analyze that. We will have a good output, and based on that we can strongly predict our output with the theorem and proof. And when we go, if in today's 2021 research, regression algorithms with the mathematical approaches are so quality of water, which type of leaves, or which classification of different types of leaves or flowers, or different types of patients. So there may be different types of flowers or this medical data set based on the, for example, a diabetic patient may have some other complications. Like that, you can have a correlation relationship between these two attributes. So based on the data sets and based on the COVID analysis, so these are the 2020 regression algorithms are mostly used along with the mathematical proofs. So when you go for these areas, you will get a good, but you have to prepare your own data set. That is the thing, your own data set. You have to make the initial research processing with the research methodologies. After that, we can apply the machine learning models. So decision tree is one of the model in the machine learning. It will be, it is a familiar traditional model. So this decision trees will have, it can predict the output based on a tree-like structure. That is, if a person is having a salary of greater than 50,000, we can have some problem. We can initiate our problem in any of the area. For example, if we choose the employee database, if we gather the information of different types of employees, and if a person is having 50,000 salary, and if we want to switch over to another job, so you can have a decision tree approach, and the machine learning algorithm decision tree will give whether he has to accept another offer or not, or if he has to accept if he want to go to another job or not. So like this machine learning algorithm, decision tree algorithm will predict the output. So like this, the system can automatically predict some outputs, and also based on the temperature and humidity. So when we give the temperature as input and humidity as input, the decision trees will automatically predict that whether tomorrow will be rain or not. So like this, it will be predicting. So the decision tree algorithm is a machine learning algorithm. So it will be very easy. The learning of the algorithm will be very simple. Just we have to give the data set. It will automatically predict whether there will be rain or not. So based on the probability. So this is mostly based on the probability. And multi-class classification algorithms. So there are many classification algorithms. So since it is having different classes, we are saying it as multi-class classification. So decision trees are also used for this classification algorithms. Name base is the name of a person who has discovered a classification algorithm. So the name of the algorithm is Bayes algorithm. And there are many versions of decision trees, random forest, boosting, like that. Neural network is a different area. It is also used for classification. In neural networks, there are many types. So the thing is, there is no need to learn and familiarize with all the models. We can choose any one of the area of interest, or we can choose any one of the problem domain. We can go for any of the algorithm. There is no need to have a good idea about all the algorithms. And when we go for K nearest neighbor algorithm, KNN means K nearest neighbor algorithm. So when we give the data, the working of this algorithm is, when you give the data, based on the distances, it will group the data, and it will find its neighbors. For example, if this number is 5, it will find by number 5 or not, or more or less if it is equal to 4.5, it will have this number, and it will classify. So it will find the neighbors and it will calculate the distance, K nearest neighbor algorithm, based on the distance it will calculate. So every algorithm will have a working methodology. Based on that working methodology, it will find the output, and finally it will throw the output. That is, this color, this class belongs to this class is voted by 2 people. This green color class is voted by 1 people. This orange class is voted by 1 people. So like this, it will classify. So when you give this data set, it will automatically classify. So how it is classifying means based on the nearby data, it will classify. So there is no need to write the program coding. These codings are automatically available in the software tools. Just we have to give the input. We have to learn the working methodology. So there are many tools available. That is, BigML is the tool I have shown you. So even if you are a beginner to machine learning, so you can go for a BigML tool. You can just test it with the input data sets, and you just randomly apply any algorithm. So you see that there will be some outputs. So when you see that outputs, you will get a clear idea about the machine learning algorithm. So you can go for BigML tool. So this is the data set of iris. It is a flower. So I have shown that it will classify the flower in either of the 3 categories. So this is a BigML tool. So it will classify like this. So it will form a tree like this. So this is the generated system generated output. Just we have to analyze this output. So in both of these items, it will display the meaning of this flower is iris. This category is iris versicolor. So it is having 100 instances. So it is nearly 66% in the data set. So like this, it will give the output. This is BigML tool, and it will automatically predict the output. So when you go, these codings are not written by me. It is automatically generated in this tool. So it will calculate based on the petal length and sepal length. Based on the petal length and sepal length, it will automatically calculate whether this flower will belong to this category or this category or the third one. So these code is automatically generated. Just we have to click the data set and we have to click the algorithm. It will automatically give the output. So when you go for naive-based classification, so I have told you that naive-based classification is a popular machine learning algorithm. Actually, it is a naive person. So when you it will also used for classification. For example, if you are giving some 500 students data, it will automatically, and if you are giving some attributes, so your aim is to differentiate the students percentage wise or category wise, means it will automatically classify and give the output. So this can also be done with the BigML tool. So this is naive-based classification, and it will use the probability formula for that. So likelihood and prior probability and posterior probability. Based on this formula, it will be calculating how much students will fall under this category. So based on this, it will find the probability, and based on the data, it will give the output. So this is naive-based classification. So another method is genetic algorithms. So actually, it was a big area. So it is mainly used for optimization problem. If you are interested in optimization problem, you can choose genetic algorithms. If you want to classify the data set, or if you are interested in probability, you can go for classification problem. Genetic algorithms, it is used for mainly for optimization problems. So I have told you that the optimization function problem will have 3 areas. That is, you have to write the function, and you have to write the decision variables. You have to declare the constraints. If you are interested in optimization problem, you can choose genetic algorithm. So genetic algorithm is given. So when you give the input data, it will throw only a best fit output. That is the meaning of optimization. So it will throw only the best fit output. So it will work under the principle of Darwin's theory, Charles Darwin's theory. So what is Darwin's theory is, whoever best fit individual will fit in the world. So that is Charles Darwin's theory. Based on that, it will find the best optimization data. So genetic algorithm is a good tool for optimization problems. And in genetic algorithm, as the name indicates, every data will be represented as chromosomes, and every data will be represented as the fitness function. Just I will give a that is function. We'll be declaring the fitness function, and we'll be declaring the variables. The variables will be taken in the form of zeros and ones. This is the internal working principle of genetic algorithm. But it can also be done easily by the software, because we just have to understand the working principle of genetic algorithm. The softwares will automatically do this work. So this is about genetic algorithm. And neural network, I think so. So based on the input and based on the function, we can generate the output. We can create models. So we can go for Python tools. If we want to write coding, that is, coding in computer science is not a very difficult task, because nowadays many packages are available. So you have to just install the packages, and you can code. You have to just change the data set, and you will get an output. The part is you have to analyze the data analytic part. So many Python libraries are available in data science. So these are all some libraries. So for mathematical, SciPy is used. For purely mathematical analysis, SciPy is used. NumPy, SciPy, these are all used. And we can write a simple 4-line coding. Even for a 4-line coding, it will generate it. Just we can give a data set as an Excel file. We can give a chart output. So we can give a visualization. We can give the output. So these codings are available in many books also. So just you have to, I have chosen the lung cancer data set. So we have to choose the data set file in an Excel. If it is a real-time data set, we have to keep the data set of Excel file, and we have to give the full path of the Excel file. So it will automatically generate the visualization chart. It will generate the histograms. That is 0% not having lung cancer, 1% is having cancer. So these are all some Python codings. So which through which we can generate some outputs. So if we give the inputs and if we give the attributes, it will take some attributes as training data and test data, and it will predict some outputs. So based on these outputs, we have to study the methodology. So it was a classification problem. So we can give some class, and the accuracy of the plots will be thrown. So this is about the Python. So there are many machine learning topics. So based on the requirement, we can move for the particular topic. And so when we, the exact categorization between supervised and non-supervised is, supervised, if you give the input data, it will find that it is an apple. Unsupervised means if we give some combinations of apples and bananas, so it will automatically classify the apples and bananas. So the input data set will be whatever input data set we are giving. Based on training, if it is predicting, that is known as supervised. Without training model, if we are giving the data, that is known as unsupervised. And so this is the screenshot of a tumor cancer cell. So where our image recognition picture will find out whether these cells are tumor cells or normal cells. So you can apply the neural network model here, and we can test the data. So train data and test data. So if we train more number of data, and we can generate the test data. So we can find whether a particular person is, whether these cells are tumor cells or normal cells. So medical diagnosis application. Here deep learning neural network is used, and we can predict some images. So whether your system will going to find out whether it is a cat or dog. So it can predict. So this is one application of unsupervised learning. So when we give some more number of images of cat and dog, so it will predict the images, whether it is a dog or cat. So like this, this will come under supervised and unsupervised. As I have given a for just a familiarization, I have given these images. For supervised means this is the type. And clustering means if we want to group some Facebook friends, we can go for clustering algorithms. So there are many clustering algorithms. K means like that there are many algorithms. So the clustering algorithm will automatically group the data. Even Facebook friends can be categorized, and what are all the different types of websites we have seen can be categorized as based on the website analysis. So clustering is another concept. Can be using BigML. So you go for cluster, you just click for unsupervised, go for it will automatically give the cluster output. So K means algorithm is a clustering algorithm. So where we can use, and this is the screenshot of clustering algorithm done in BigML. So BigML, when you go for click cluster, it will give the output. The only thing is we have to analyze this output, and mathematical approach behind this algorithm we have to analyze. So this is the diagrammatic output. The clusters are formed. It will group data, that is known as clustering. So it will group the data, and it will give a Excel file also. It will give the output in the form of Excel file also. So it will give how many persons are having, in which age, what is the insulin level, what is the BMI level, what is the blood pressure level. It will throw the output. And this is the code. We have not written this code. It is an inbuilt code. So this is a deep learning model. So deep learning will work based on the input, and it will generate the output. It is another classification algorithm neural network. It will also can predict the output, whether I have given whether it is a cat or dog. So it will find out. So there are many deep learning models. These are the different deep learning models. We can choose any one. Recurrent neural network is the basic model, familiar model. Convolutional network is also the familiar model. So based on this, we can do the research. These are all the inputs. Based on the weights, we can calculate the neural networks. These functions will be sine functions or cos functions, like that. So this is about neural network. It is a big area. So in mathematics, we can also go for interdisciplinary research as natural language processing. Natural language processing is, that is whatever we talk, the system can understand. So that is known as natural language processing. So when you go for natural language processing, we can sentiment analysis is the area now it is going on. That is consumer behavior. So when I like the, for example, if you are going to surf about the watches, so in Amazon, so automatically the new brand watches will be given for you as a recommendation system. And sentiment, if you are sad, it will be giving some, the system will give you some inputs. If you are happy, the system will give you some inputs. So like that, the sentiment analysis is one part of natural language processing. And many types of sentiment analysis are there. These are all the framework. So when you go, it is a just I have given what is natural language processing. Actually, it is a simple tool, a simple thing. You can go for natural language processing also. Sentiment analysis is a very interesting thing. Based with the mathematical approach, you can go for that interdisciplinary research also. So these are some screenshots of that is sentiment analysis. So when you have a blog means, so if you post a blog, that is, if you are conversing something about the election means, all these matters will be stored in the blog. Based on that, a sentiment report will be created by the particular website. So it will create whether in the forthcoming election, which group will win. So like that, it will give a sentiment analysis approach. So for sentiment analysis, the words will play a vital role. For example, if you go and type in the Google, you will automatically get all these things. So based on that, it is displaying more number of items. So this is sentiment analysis. This is natural language processing. So where the system will automatically understand what you need. And there are many subdivisions in natural language processing. So the nouns and verbs will play a vital role. So we can program the natural language processing using Python. So it will automatically search our, it will find the text. If I give a text, the system will understand each and every word in my text and it will react according to that. So this is a simple Python code. Using NLTK package, we can do this. So this is natural language processing coding. So these are all some eye openings about machine learning for the interdisciplinary research as well as some mathematical applications. So you can raise your questions based on this.
Any questions from the participants?
Good afternoon, madam.
Yes, sir.
The data stored for different activities, say the
Yes,
Twitter,
sir.
Facebook, LinkedIn, Instagram.
Yes, sir.
All these
Yes.
data are stored in different places for each application.
Data storage, sir. So for data sets, I have given a presentation. That is, the data sets are available in many websites, sir. UC repository, Kaggle dataset, and when you browse in one one slide, I have given the part of the data set. Websites of name of the websites. Even in government websites, there are many data sets.
But
So we can go for that particular website.
due to application of
Yes,
these things,
in one place it will be stored. If you want medical data set, there will be medical data set.
so for all these places, same place data is stored or duplication happens.
That is for Facebook data set. I have given an example as Facebook data set and Twitter data sets there. Many real-time data sets are available. In these particular websites, we will be having many data sets available, sir. It is available. When we go for these websites, many different data sets are available. Even diagnostics data set, medical diagnosis data sets. Yes, they have collected and placed it in one place. For the research, there are many research websites where data sets are available. For research, particularly for research, they have given this data sets.
What I say, common data which is not particular for particular application, that can be stored in one place so that they can reduce the big data problem.
Yes, sir. Yes.
Any other questions? Hello, any other questions from the participants?
Hello, good morning.
Hello,
I'm
good morning, sir.
Yes, sir.
I'm calling from Nigeria. Please, in her presentation, she has shown a slide that one of the slides is showing a real image, while the other one is showing the predicted image. I want to understand the difference. The difference between how is she getting the predicted image.
Madam, sir, I am not clear.
Okay, my question is that in one of your slides, you have shown predicted image and real image. Then I want to ask, how is the machine can get the predicted image?
Machine will predict the image, sir.
You have shown a slide showing a predicted image and real image.
Yes, sir. That is, there are many image recognition tools in machine learning. So which will predict the image. Using neural network also we can predict. In convolutional neural network, we can give the images as input and we can predict. The images can be predicted using image recognition techniques. For example, if you go for neural network model, you can give many type of images as input. Images as input, it will automatically predict the images. When you give a best training, it will automatically predict the further images, future images.
Okay, my question is that how will the machine predict the image without seeing the real image? Would that be possible?
Sir, how the?
I said, how can it predict the image without seeing the real image? That's my question.
How it is predicting the image. That is the thing I have told you, that we have to give we have to give the output. We have to give the predicted image also. We have to give the predicted image. We have to give the actual image, and we have to give the input, and it will predict the output. We have to give both. For neural network models, we have to supply the images. We can supply the images as well as the actual outputs. After a huge training, it will automatically predict the images.
Okay, thank you. Thank you.
Any others? Hello, any other participant? I think nobody is there, ma'am.
Yes, ma'am.
Thank you very much, ma'am. Thank you very much for
Thank you, ma'am.
this brainstorming using machine learning algorithm in data science research. Most of us daily will see the weather report. That tomorrow it's whether it is sunny or rainy, but we don't know that machine learning is behind that one. Every common man, just I'm telling about.
Yes, ma'am.
And you have given good applications about this one. That means that signal board with unknown language. I think some this in Google in Google also this language. So it converts with the help of this machine learning itself.
Yes.
No matter. Yeah. And
Yes, ma'am.
you have
Yes,
given
ma'am.
about the predicted faces by AI. You have given that. You have explained about that one, about the relation between the big data, data analysis, data science, and you have told all these are interrelated. And
Excuse me, ma'am.
thing, and everybody knows that maths is behind every computer science language or algorithm. So here also this matrix, data, linear algebra, probability theory, multivariate calculus, these are all behind this machine learning. Because all the people now at the degree level or at PG level, they study all these things, but they don't know where we use this one. So we have given a brief idea about all these things, ma'am, and about the regression types and the regression algorithms which are used in COVID and dengue fever and water quality prediction, and about the decision tree, genetic algorithms, neural networks. You have given a brief idea, madam, about this machine learning. Thank you very much, ma'am. I hope our participants have enjoyed
Thank you,
with your nice presentation. Thank you, ma'am. Thank you very much, ma'am. Thank you very much for accepting our invitation and for giving this nice lecture in this session, ma'am.
It's my pleasure, ma'am.
Okay, ma'am. Thank you, ma'am. I thank all the
Shall I
participants
quit the
for
meeting?
maintaining silence throughout the session, and I hope you have enjoyed the session. So tomorrow we'll meet by 2:30 p.m. sharply. After the session, the valedictory follows, ma'am. After the session,
Okay, ma'am. Shall I quit the
session
session?
starts by 2:30. After that, the valedictory follows.
Okay. Shall I quit the session, ma'am?
Okay, ma'am. Okay, thank you, ma'am. You can leave.
Thank you. Okay.
एक्सक्यूज मी मैम, ओपन नहीं हो रहा.
क्या ओपन नहीं हुआ? मीटिंग लिंक, फीडबैक लिंक.
यस मैम.
It's opened, ma'am. You try once again. Please check your network and do after some time. It's working.